Sure,
Who are
yeah.
they?
They are Scrooble, and what it is it's a multimedia cooperative party game, and so we'll see what they have to show us now.
Hello everyone, I'm Leo, and this is Jeannie, Michael, and Francisco. Everyone loves to doodle, so we made Scrooble, a multiplayer game in your browser that lets you choose and draw a word while your friends race against each other to be the first to guess the word. Points are awarded based on a timer, where the quicker you guess the word, the more points you get. At the end of the game, the player with the most points wins. The roll of the drawer cycles between players until 3 turns have passed. Let's enter our name and see what a normal turn looks like inside of Scrooble. So, we're playing with our friend Dakota, and it's currently Dakota's turn to draw. At the top of the screen, I see that I have a hint. We have this little hangman style strategy where the word I'm guessing has 5 letters, and that's my hint for how long the word I'm guessing has to be. So I know that Dakota's drawing a word with 5 letters, and so if I look, I see that the word looks like a heart, and I guess that. I didn't guess the correct word, so I guess again. I see he draws a little more, and now I know the word's an apple, and so I type apple, and let's see, and look, it looks like I get the word right. So now here's Francisco to talk about what a normal turn looks like as the drawer in Scrooble.
Thanks, Leo. So I can tell I'm the illustrator in this round because I get a word prompt at the beginning with 3 options of words to draw. So I choose a word, and I have a variety of colors and stroke widths to choose from to draw this. And as I draw, the other players guess what I'm drawing, and if they guess correctly, they win points. And at the end of my turn, the timer runs out, and then it becomes someone else's turn to draw. So when we decided to make this project, we realized that React does not have a Canvas library, so we had to make our own Canvas component. And the big question when crafting that was, how are we going to transmit live in real time the illustration that the drawer is making from the illustrator's computer to all the guessers' computers immediately? So we had to take into account the color and the stroke width, as well as the coordinates of where on the canvas the drawing was being made. So Jeannie's going to talk about the technology we used to make that happen.
Thanks, Francisco. So because we had so much data to send from one user to another, including drawing coordinates, brushstroke colors, brush sizes, and the player's guesses, we decided to use Firebase as our backend. Firebase allowed us to send live updates to all the players in the game. This is a diagram showing our data flow during a game. So the illustrator draws on the canvas, which sends the drawing data up to Firebase. Meanwhile, other players are waiting for changes to the canvas. And then, once the drawing is sent to Firebase, it gets distributed to all the other players' computers, and the drawing gets rendered on their screens. Firebase was useful not only with our canvas feature, but also our guessing feature. Basically, players are allowed to guess as long as they're not the illustrator, and then their guesses are sent to Firebase and distributed to all the other players in the game. And now Michael will tell us about our optimization process.
Thanks, Jeannie. You might have noticed that we are sending and receiving a lot of information to and from our database, especially with the canvas. Originally, we were reading and writing information while the person was drawing, which was far from ideal because every new pixel triggered a data fetch, which turned hundreds of data points into thousands of data reads. Excuse me. So we didn't see that this was that big of a deal when we were coding. But we quickly realized that we needed to optimize our approach when we maxed out our data plan by testing with just 4 players. So the major change we made to improve our data usage was to only send information at the end of a stroke when the player lifted the mouse, basically. And this actually exponentially reduced our data usage. So now we can easily scale our application indefinitely to accommodate more users. If you're interested in playing, you can find our app on Scrooble.io. And if you're interested in checking out our source code, you can find our GitHub at the bottom. Thank you.
All right, to vote for Scrooble, like the post, like their pinned comment. Really cool take on Pictionary, honestly. I think that they ran into an issue that I thought early on using Firebase, you're doing a lot of read writes. You're going to, trying to get around using WebSockets to deal with this real-time capabilities. And I think they found a really good way of sort of managing those issues. So that was pretty cool to me.
Yeah, great job.
Yeah, pads have a lot of data points, and those data points going across the wire, it's a lot of data. And if you're doing that at every movement of the mouse, then that's going to be a lot. So I thought that their solution there was very, very prescient.